Hi everybody. So we're going to be going over the worksheet that you have that's coming up due. It is going to be called Exponents with Multiplication and Division. It is a fairly new concept and I suspect you're going to have a little bit of difficulty with it. Please, please, please ask for help, guys. I can Skype with you. I can go over it with you one-on-one. This is not an easy concept and you are going to have to pay attention to the rules. A couple of things I wanted to review from problem set 29. Which was a new concept. I want to make sure that you understand because from the homework it doesn't seem like you guys are grasping that. Okay, so first thing is, whenever you have a variable that has a 0 exponent, that answer will always be 1. Anything to the 0 power is 1. It doesn't matter if it's 5 to the 0 power, 25 to the 0 power, 100 to the 0 power, they're all going to be 1. Okay, so that's the first thing. The second rule is called the product rule. The product rule tells us when the variables are the same, in this case I have x and an x, so when the base, not the variable, when the base is the same, then I add the exponents. So xm plus xn would equal xm plus n. And then the third rule was a fairly new rule, where it says we have 1 over x to the n power. This is the one that was new and everybody was having a little bit of difficulty with. Basically, what it's allowing me to do is every time I have a number, it doesn't matter whether it's in the numerator or the denominator, I can move the number to the other part of the fraction as long as I change the sign. So in this case, I have 1 over x to the n power. I can move basically I'm going to give the reciprocal. So the reciprocal of 1xn would be xn over 1. So I didn't show that step, but I can show you. It's going to be, it would look like this. It would be xn over 1, but then you have to add a negative and reduce it, so it becomes x to the negative n power. So I took the 1x over n and I put the xn in the numerator, the 1 in the denominator, and I changed the sign. That's going to be really key and very important as you go forward, okay? Now, let's start with number 1 on the worksheet. The first one says 6c to the 5th power d squared times 2c d to the 6th. So I'm multiplying, so I'm going to use the exponent rule, okay? Whenever this actually should be times, not plus. I didn't catch that. So when you multiply two bases that are the same, you add the exponents. So here's the base, CD, CD. Those are the same. So I'm going to add the exponents. Now notice the 6 and the 2 are not the same, but those are not my base. Those are my coefficients. Those don't have to be the same. First thing you want to do is put 1s on any variables that don't have any numbers. Second thing, multiply the coefficient. So 6 times 2 would be 12. After you multiply the coefficient, then you put the letters in alphabetical order, and then you count the number of exponents. The c to the 5th plus the c to the 1st would be c6. d squared plus d6 would be d to the 8th. So this was a simple problem. The answer is 12 to the 6th, d to the 8th. The next one I'm going to do is number 3 on that worksheet. And that one says s times s to the negative 5th power. But if you go back and read the directions, it says simplify. Your answer needs to be only positive exponents. That's going to be different than what you did on lesson 29. Lesson 29, I told you did not have to make them positive unless they specifically stated. Well, this worksheet says make your exponents positive. So the way you want to start is put a 1, just like we did over here. Then we multiply any coefficients. In this case, there's a 1 and a 1, so 1 times 1 would be 1. We don't need to put that. And the third step would be to add the coefficients. So, the exponents. So we would say s, 1 minus 5 is minus 4. But wait, minus 4 is a negative number. So we go back to our rule and recall that you can move the fraction to the other part. You can move the part of the fraction to the other portion of the fraction and come up with the correct answer. So you're going to say, put this over 1 so that you create a reciprocal. That's the first thing. Then you're going to flip it and you're going to say 1 over s to the 4th. And notice I dropped the negative. One more time. Let me spread this out a little bit. I put a 1 underneath. Now I have a fraction, so I can flip it and put the 1 on top. Then I put the s on the bottom, and I put the 4 as an exponent, but the negative becomes a positive 4. This is your answer, 1 over s to the 4th. If you don't do this step, where you put the 1 as a denominator to begin with, you're not going to see that it actually has something in the numerator, and you would probably come up with an answer that says s to the 4th, which is what I was seeing in your homework. So again, as a precaution, put a 1 so that you can flip it and then change the exponent. Now you have a positive exponent, so it's 1 over s to the 4th. Okay, let's do another example. All right, let me take these away, and I'm going to be doing, let's see, let's do example number 4. Okay, I'm going to do 4. Okay, example 4 says 2b to the 3rd power, k to the 6th power, all over 5b squared, k to the 4th power. Okay, so let's absorb that for a minute. My numerator is 2b to the 3rd, k to the 6th. My denominator is 5b squared, k to the 4th. Okay, so keep it really simple. The first step I said was to multiply the coefficients. But in this case, you can't multiply the 2 and the 5 because they're already fractions. So what you want to do is leave those alone. So this would be 2 over 5. You wouldn't do anything with that. You cannot multiply them. They're a fraction, so you leave it alone. The only thing you would do is reduce it, if you can. In other words, if this was 25 over 5, then you would divide 25 by 5 to come up with 5. But if you can't reduce it, then leave it alone, okay? The next step is to simplify anything on top. You cannot. Simplify anything on the bottom. You cannot. What I mean is, in the numerator only, if there's multiple b's or multiple k's, simplify them. Do the same with the bottom. If there's multiple b's or multiple k's, simplify them by adding them. If there's not, then you will just want to go ahead and you're going to take the 3 and the 2. I want only positive exponents. So this is where this is going to get a little bit tricky. We know that when we take b to the 3rd times b squared, we're going to add to get b to the 5th. Okay? The problem is we're not multiplying b to the 3rd and b squared. The line means divide. So this is actually being divided. So when you multiply, when you're multiplying variables that are the same, you have to add. But when you divide variables that are the same, you have to subtract. So in here, you're going to subtract the 3 and the 2. So 3 minus 2. And you're going to end up with b to the 1st. But what you have to be careful about is the b to the 1st goes on top, not on the bottom. Because there are more b's up here than there are here. Okay? Now let's do our case. Again, we're dividing them, we're not multiplying them, so we're going to subtract 6 minus 4, and we're going to get k squared. So my answer is 2/5, which stayed the same, b, because I subtracted the 3 minus 2, and k squared, because I subtracted the 6 and the 4. Remembering that there are more b's on top than there are on the bottom, so my answer has to be b on the numerator. And there are more k's in the top than there are in the bottom, so there has to be more, the k's have to go in the top. On the next part of our video, I'm going to show you why that makes sense. Okay? This is really complicated.